Lecture 17. God, the argument from design.
The teleological argument. It sounds intimidating, but really it's just the argument from goals, or as it's known today, the argument from design. And it's probably the most academically cited argument for God's existence. But the argument is also directly related to questions about the very nature of the universe and why it is the way it is. So, just like we did with the cosmological argument, you should keep in mind such questions as we consider the teleological argument too. The teleological argument is arguably the most famous argument for God's existence, since a version of it supposedly convinced the philosopher Anthony Flew, one of the most famous atheists of all time, to believe in God. Although this probably sounds impressive, it's unclear whether it actually is impressive. First, if Flew converted at all, it was only to deism. A deist is someone who thinks that God created and designed the universe, but then basically just forgot about it. Such a God is like a watchmaker who winds up the universe like a watch and then just lets it run without any concern for how it turns out. Obviously, if Flew converted to deism, he is not a traditional theist and certainly couldn't be considered a Christian. His conversion also happened when Flew was older and had weaker mental capacities. Many thus wonder whether his conversion should be considered genuine. Some people think those who presented the arguments to Flew hornswoggled him a bit, saying things that aren't scientifically accurate to make the argument seem better than it is. After all, they did ghostwrite the subsequent book, There Is a God, How the World's Most Notorious Atheist Changed His Mind. Others claim that Flew never converted in the first place or retracted his conversion later. Still others suggest that subsequent statements made by Flew contradict these points and that he really was converted. But whether he was really convinced by the argument is not really our concern here. We are concerned about whether any version of the argument is actually any good. Are its premises true? Do its premises really support its conclusion? Although Thomas Aquinas, probably the most recognized of the Catholic medieval philosophers, put forth an earlier version of the design argument as his fifth way to prove God's existence, the most famous design argument belongs to the 18th century philosopher William Paley. He points out that if you stumbled upon a stone, you would likely not conclude that the stone had a designer. But if you stumbled upon a watch, you would certainly conclude that it had a designer because it clearly has parts that were placed with a purpose. Paley argues that, in the same way, biological beings like you and me have parts placed for a purpose. For example, your eyes seem to clearly have been placed with the purpose of processing visual information from the outside world. Thus, we must have a designer. Once in grad school, on a day I was teaching Paley's argument, I walked into the classroom to find that someone had left a watch, quite inexplicably, on my lectern. I, of course, used it as an example all class period long. But to this day, I don't know if it was a coincidence or if a clever student was pulling a subtle joke. At any rate, although it was probably thought to be a good argument given what people knew at the time, Paley's argument can no longer be considered a good argument. Put simply, the theory of evolution, one of the most well-established theories in all of science, shows that Paley was wrong. Why? Because it shows how living organisms can have parts that have particular functions without those organisms being designed. Roughly put, we have the functional traits we do, like a functioning eye, not because some designer gave them to us for the purpose of seeing, but because past random mutations gave our ancestors those traits, and those traits were advantageous for survival and reproduction and eventually worked to fixation. Now, it's probably important to note that, contrary to the claims of some, evolution is not incompatible with theistic or with Christian beliefs. The fact that Paley's argument fails to establish God's existence doesn't mean that God doesn't exist. As we've discussed before, a bad argument to a conclusion doesn't mean that that conclusion is false. In addition, although evolution is incompatible with a literal interpretation of Genesis 1 and 2, one need not embrace such an interpretation to be religious, or even to be a Christian, any more than one must be a terrorist to be a Muslim. Most religions and religious organizations in the world are openly accepting of the theory of evolution, just like most Muslims oppose terrorism. Paley's failure also teaches us that it's dangerous to justify your belief in something by using that thing as an explanation for a currently unexplained thing. Why? Because science is really good at explaining things. A large portion of what was previously unexplained, or even seemed inexplicable, is now explained by science. And although it's questionable as to whether we will ever one day explain everything, for any given thing that is now unexplained, it's likely that it will be explained one day. So if your reasons for believing in something are tethered to something that is currently unexplained, chances are your reasons for belief in that thing will eventually be pulled out from under you. But the fact that evolution so soundly defeated Paley's argument gave rise to another kind of design argument, the argument from fine-tuning. The first such argument points out that it seems that the Earth is fine-tuned for evolution to occur. So yes, we need not hypothesize the existence of a designer to explain our biological parts. Evolution can do that. But we need an explanation for why evolution could occur on the Earth to begin with. It seems that conditions on Earth are just right for evolution to occur. So fine-tuned that it seems that someone intended for life to evolve. How so? Well, we're just the right distance from the sun, not too hot or not too cold. We have an abundance of water and a single large moon that steadies our tides and our climate. We have an atmosphere that contains air for us to breathe and provides us protection from meteors and meteorites. The star we orbit and our orbit around it is stable, as is our planet's rotation. We even have a magnetic field that is emitted from the iron core of our planet that defends us against solar radiation. But like the cosmological argument, as an argument that points specifically to the traditional perfect triomni God of theism, this argument falls short. A being who fine-tuned the Earth for evolution would need to be powerful, but not necessarily perfect or all-powerful. Nevertheless, the argument suggests some kind of deity must be responsible for Earth meeting all of those conditions. But the main problem with this argument is that it mistakes the odds. It suggests that such fine-tuning is improbable when actually it isn't. Consider this. What are the chances that someone would win the lottery? When you stop to think about it, you realize that this question is actually a bad question. It's ambiguous. It depends on what the word someone means. What are the chances that a particular person would win the lottery? Very low. What are the chances that at least one person would win the lottery? It's a near guarantee. And even though for any particular person the likelihood that they will win is low, when some particular person does win, we need not invoke a designer to explain why they did. What are the chances that some planet would have all the conditions it needs for evolution to occur? Well, that depends on what you mean by some planet. What are the chances that some particular planet would have the right conditions? Well, very low. But what are the chances that some planet somewhere in the universe will have all the right conditions? Given the size of the universe, it's a near guarantee. There are billions upon billions of galaxies, all with billions of stars and planets orbiting them. Therefore, the chances that some planet orbiting one of those stars would have everything it needs for evolution to occur is practically guaranteed. Some planet was going to win the lottery. And so, although the odds that this particular planet would have the right conditions for life is low, that life evolved on this planet does not need an explanation any more than someone winning the lottery needs an explanation. In fact, the more we explore the galaxy, the more common it seems that planets are. So the existence of many life-conducive planets just in our own galaxy may be a near guarantee. So the fact that there are many planets, each with a chance of having the right conditions for life to evolve, means that we need not invoke a designer to explain why our planet has the right conditions for life. But isn't there just one universe? And aren't the laws of the universe set up in such a way to guarantee that life evolves? If so, might we need to invoke a designer to explain why our universe is fine-tuned for life? Indeed, we might. And that is the basis of the fine-tuning argument that philosophers and scientists are most concerned with today. This is the version that supposedly converted Anthony Flew. The argument goes like this. Almost everything about the basic structure of the universe, its laws and its initial state, seem to be balanced on a razor's edge for life to evolve. That is, the universe seems fine-tuned for life. Why? Because if any one of its forces or constants were slightly different than it is, then life could not evolve. And it seems that this kind of fine-tuning is much more probable on theism than atheism. Sure, it's possible that the universe could just so happen to be so fine-tuned without the work of an intelligent force, but it seems unlikely. Whereas the universe being fine-tuned, that is exactly what you would expect if it were created and designed by some kind of benevolent deity. It's as if all the dials that determine what the laws and constants that govern the universe are, those dials seem to have been set by someone in the one and only position they would have to be set in order for life to evolve. So what are these laws and constants that are balanced on a razor's edge? How exactly are the dials fine-tuned? Well, the number of supposed fine-tuned factors is long, so let me just mention a few of the important ones usually espoused by those who defend the fine-tuning argument. It seems that if the strong nuclear force, which holds together the nucleus of an atom, were any weaker or stronger to the slightest degree, then atoms would collapse or fly apart. Too much, and all the protons get pulled into the nucleus. Too little, and the protons fly off into oblivion. It also seems that if the weak nuclear force, which makes possible radioactive decay, were stronger or weaker to the slightest degree, there would either be too many or too few heavy elements. If gravity had a slightly different strength than it does, stars would either be too weak or too cool to support the evolution of life. If electromagnetism were slightly different, or if the ratio of electron to proton mass were slightly different, it seems that chemical bonding wouldn't allow for the evolution of life. And if the ratio of electromagnetism to gravity were slightly different, stars would either be too big or too small. You want more? A slightly different ratio of electrons to protons in the universe would seem to prevent galaxy, star, and planet formation. And according to Stephen Hawking, if the electric charge of the electron had been only slightly different, stars either would have been unable to burn hydrogen and helium, or else they would have not exploded. And if the rate of expansion of the universe were different, it would either collapse back in on itself or expand too quick to form galaxies. For example, if the mass of neutrinos were 5 times 10 to the 34th kilograms instead of 5 times 10 to the 35th kilograms, the additional gravitational mass would result in a contracting rather than an expanding universe. Are you convinced? The fine-tuning argument sounds very impressive, and some even think it's conclusive. However, there are actually a number of very serious problems with the argument. First of all, even if the universe is fine-tuned, it's not clear that the purpose of this fine-tuning is the evolution of life. Given the relative scarcity of life that exists in the universe, even given our most liberal estimates, life does not exist very many places in the universe, and when it does, it doesn't exist for very long. It seems that what the universe is actually fine-tuned for is galaxy formation. That is the main thing that the universe does, produce galaxies. Life is just an unintended consequence of galaxy formation. To suggest that the universe is fine-tuned for the creation of life is a bit like saying that your toaster is fine-tuned to fill the crumb catcher on the bottom of it. That is something that it does do, but that's not its main purpose. So, even if the universe is fine-tuned, it does not point to the existence of a traditional theistic God, or even a non-traditional one for that matter. Secondly, the argument seems to invalidate itself. If the complexity of the universe demands a fine-tuner, then the creator of that universe would demand a fine-tuner as well. In fact, that fine-tuner would demand a fine-tuner even more than the universe itself, because designers are more complicated than the things that they design. But then the designer of that designer would require a fine-tuner, etc., etc. So either you have an infinite regress of fine-tuners, each fine-tuning the next, or somewhere along the line, you're going to have to end that regress with something that itself needs fine-tuning, but doesn't have it. Something's complex design is just going to have to be a brute fact. But if you're committed to something's design being a brute fact, it's just simpler to say that the universe's design is a brute fact and leave it at that. There's no need to interject one more new thing to be its designer if you're just going to have to admit that the new thing itself needs a designer, but actually isn't designed. Third, there seems to be no good reason to suppose that the values that the fine-tuning argument mentions could be different than they are. The fine-tuning argument suggests that the universe must be fine-tuned because if any of its laws or constants had a different value, then the universe could not support life. but that assumes that the values could be different. Yet there is no argument presented for why they could be different than they are. Of course, one can imagine them having different values than they do. For example, one can represent the current values that they have with numbers, and then you can just simply imagine different numbers. But that doesn't mean that it's actually possible for the laws and constants in question to have different values. The constants and ratios that the fine-tuning argument mentions could be what they are necessarily. The fact that we can imagine them being different doesn't mean that they actually could be different. And if they can't be different, then they don't need an explanation for why they are different. Additionally, the motivation for this version of the fine-tuning argument started with the assumption that there is only one universe. And if the universe only had one chance to get it right, then the chances that it got it right are very low. But this follows only if there is only one universe. Yet we are now discovering that there are reasons to think that there are multiple universes. It's possible, for example, that there are different universes that exist on different dimensional planes. Or it could be that the universe itself is perpetually oscillating. It explodes from a big bang, it expands, it collapses back in on itself all the way back down to a singularity, and then it re-explodes. That is not the prevailing theory, but it is possible. What is the accepted theory today is that the universe is continually expanding at an exponential rate. So quickly that it will eventually reach what is called a heat death, where all particles of the universe will be completely expanded apart and it reaches a vacuum state. As we saw when we talked about the cosmological argument, matter can be created spontaneously in a vacuum, and the universe itself may have originated from a fluctuation in the giant vacuum which is the quantum foam. If the universe expands into nothingness, we will again be back to pure quantum foam and conditions conducive to the creation of another universe. And then that universe could expand out again into a pure vacuum, which would create another universe, etc., etc. And, as we shall see later in the course, some interpretations of what we observe in quantum mechanics suggest the existence of multiple universes as well. Regardless of the reason, if there are multiple universes, it's not unlikely that one would have laws that are conducive to the evolution of life, especially if every universe's laws are set at random. Some universe would have to win the laws of life lottery. But what I find to be the most fascinating objection to the fine-tuning argument is this: fine-tuning is not actually improbable. There are actually a number of reasons for thinking this. Let's consider each in turn. First of all, to make it seem improbable that the values in question have the values they do, the fine-tuning argument assigns an equal probability to all possible values that they could have. Yet with most things, this is not how it works. All values are not equally probable. Consider an example borrowed from the contemporary philosopher Neil A. Manson, where Tiger Woods takes a chip shot up toward the pin. What is the probability that the ball will land within 6 feet from that pin? Well, the probability is pretty high. And notice that the probability is high even though there are a large number of factors that have to be just right in order for this to happen. If one of those factors took one of the infinite number of values that they could have taken, the ball would not be anywhere close to the pin. Think of all the other places the ball could land, yet it seems very likely that the ball will land at least 6 feet from the pin. Why is this? Because Tiger Woods' skill gives a certain probabilistic bias to certain values that those factors could have. They make it more likely that his club will have a certain range of pitches, powers, and trajectories. Now, you might think that this is a bad example since Tiger Woods is an agent, a being that gives a certain bias to those values. He fine-tunes his swing. And the fine-tuning argument is suggesting that God is an agent that gives a certain bias to the values of the universe. But the point is that most probabilities have a bias, regardless of whether that bias is explained by a person or by natural conditions. So unless there is evidence that no such bias exists for the factors that govern the laws and constants of the universe, we can't assign an equal probability to all of those values, which the argument does. Second, the fine-tuning argument exploits misleading units of measurement to make the fine-tuning seem much more amazing than it is. Consider another example. Again, I'm borrowing from Manson. Take Michael Jordan. What are the chances that Michael Jordan would be the right height to play basketball? Well, If Jordan's height differed by just 1 × 10⁻16 of a light year, he would not be able to play basketball. He would either be too tall or too short. So his height must be fine-tuned, right? No. 1 × 10⁻16 of a light year is a whole meter. It's not likely at all that Jordan would have been a whole meter taller or shorter than he is. But by expressing the different possibilities of his height in terms of light years, an extremely unproportional method of measurement, I have made the fact that Michael Jordan has the right height to play basketball seem much more amazing than it is. The fine-tuning argument does the same thing with all of the values it mentions. For example, it told us that if the mass of neutrinos were 5 × 10⁻34 kilograms, instead of 5 × 10⁻35 kilograms, the universe would contract rather than expand. But neutrinos are super tiny particles, and the fine-tuning argument is expressing their weight in kilograms, the same unit of measurement used to express the weight of human beings. This fact seems much less amazing if you put it this way. Neutrinos could have a mass 10 times greater than they do, and we would still have an expanding universe. This actually expresses the same fact, and it obviously shows that the weight of the neutrino is not nearly as fine-tuned as it seems to be when it's expressed in kilograms. Another objection is found in the fact that the values of the probabilities in the conclusion of the fine-tuning argument are either meaningless or they're worthless. Why? Well, you can only make sense of probabilities if you are working with finite amounts. 1 in infinity is a meaningless probability. Suppose I tell you to guess the number I'm thinking, and that it could be literally any number. There are infinitely many. What are the chances that the number I'm thinking of is between 0 and 10? 1 in infinity, because there's an infinite amount of numbers outside that set. But what are the chances that it would fall between 0 and 1 billion? Again, 1 in infinity, because there's an infinite amount of numbers that fall outside that set. 1 in infinity is a meaningless probability. But there are an infinite number of values that the parameters of the universe could have, granting that they could have different values in the first place, because you can represent their values in numbers, and there's an infinite set of numbers. So to figure a meaningful probability regarding fine-tuning, you'd have to select some finite set of values and then lay down probabilities based on the size of that set. You would have to say that, for example, the value that some particular property could have is between 0 and 100, and so the chances that it would have the right value are 1 in 100. Now, I just chose the range between 0 and 100 arbitrarily, but that's the point. The size of the set that you would select to figure the probabilities could only be selected arbitrarily, and how likely the needed value ends up being depends solely on the size of the set that you select. If you select a small set, the likelihood would be really high, and if you chose a big set, the likelihood would be really low. So, whether or not fine-tuning is improbable depends solely on one's arbitrary choice, and if so, anyone could choose anything they like and make the fine-tuning of the universe as likely or unlikely as they want. But any such pronouncement would be completely worthless. So the claims made about probabilities by the fine-tuning argument are either meaningless or worthless. Now, the last objection to the fine-tuning argument actually exposes a fallacy committed by the argument. I call it the only one way to make a square fallacy. Recall the reasoning of the fine-tuning argument is this. If any one of the many laws or constants that govern the universe were different, then life could not evolve. From this, they concluded that there is only one set of values those laws and constants could have for the universe to be compatible for life. And so, they reasoned that the likelihood it would have that particular one set of values is low. But consider this exactly parallel line of reasoning. I am walking along and I find a square, consisting of lines exactly 1 inch in length. I rightly observe that if one of the sides of the square were slightly shorter, then the figure would no longer be a square. I then conclude from this that the only way to make a square is with lines exactly 1 inch in length. Obviously, this argument is fallacious. Yes, changing one side would make it not a square anymore, but if multiple sides changed in proportion to each other, it would still be a square. In fact, there are an infinite number of ways to construct a square. In the same way, changing only one constant might make the universe uninhabitable. This is true. But changing more than one constant might compensate for the changes in the others and make it still habitable. So it simply doesn't follow from the fact that changing one value would make the universe uninhabitable, that the values the universe has are the only ones conducive to life. So the conclusion of the fine-tuning argument simply doesn't follow from its premises. What's more, the physicist Victor Stenger has shown that, instead of just imagining one change, if you allow for changes in all the governing factors and allow them to be set randomly, you get a universe conducive to life about 50% of the time. So there actually is more than one way to set the dials and get a universe conducive to life. And getting one fine-tuned for life is not unlikely at all. Even more astonishing is that many of these supposedly fine-tuned values are intrinsically linked. Changing one necessarily and automatically changes the other and keeps them in balance such that galaxies, stars, and life are possible. This is a result of conservation, which is an intrinsic property of spacetime itself and thus demands no explanation. For example, the conservation of energy necessitates that the universe's expansion rate and its mass density are what they are. They literally can't be different than they are. The mass of neutrinos is also dictated by their number. If there were more neutrinos, then they would all be lighter. And if there were fewer neutrinos, they would all be heavier. There can't be too many of them, and they can't be too heavy. Once again, the failure of the fine-tuning argument doesn't mean that God doesn't exist. A bad argument to a conclusion does not mean that the conclusion is false. It just means that the fine-tuning argument doesn't demonstrate God's existence. If you want to demonstrate God's existence, you're going to have to rely on another argument, or simply take it on faith. Given the failure of the other arguments we have considered, it's probably unlikely that you're going to find another argument. So you're likely just going to have to take it on faith. Now, whether faith is acceptable, it's often said to be a virtue, that's another matter. But it is an epistemological matter, not a metaphysical matter, so we will have to save that topic for another course. But the arguments we have just considered, especially the cosmological and teleological arguments, have brought up very metaphysical questions, questions about the very nature of the universe. Why does the universe exist? And why is the universe like it is? Ultimately, the best answers may simply appeal to brute facts. The universe just is, and it just is the way it is. But, we still wonder, exactly what way is it? We've talked about pure vacuums, the space that seems to exist between objects where there is nothing, but is space itself a thing? Something in which objects rest? Or is it literally just nothingness? It is questions like these that drove the most famous scientist of all, Albert Einstein, to develop one of the most successful and famous theories of all time, relativity. It is to understanding both general and special relativity and the metaphysical questions they raise that we shall turn in the next lectures.